Welcome to the DIY Honda Garage channel. The DTC P2126 indicates an issue with the Accelerator Pedal Position, APP, Sensor B, specifically referred to as TP Sensor E. When this code is triggered, it signifies that the APP Sensor B is detecting voltages either lower than 0.20 volts or higher than 2.51 volts, indicating it is out of its specified operational range. This sensor plays a critical role in translating the position of the accelerator pedal into a voltage signal that the Powertrain Control Module, PCM, uses to manage engine performance. The APP sensor is located on the accelerator pedal assembly, making it essential for proper throttle response in the Honda HRV. This error can lead to performance issues, such as poor acceleration or unexpected engine behavior, which can be frustrating for the driver. Troubleshooting this code involves a systematic approach to verify the operation of the sensor and associated wiring. Understanding this DTC is crucial for diagnosing potential failure areas in the vehicle's electronic system. The error associated with DTC P2126 pertains to the APP Sensor B, which is integrated within the accelerator pedal assembly. This sensor monitors the position of the accelerator pedal and transmits corresponding voltage signals to the PCM to regulate engine performance. During a malfunction, the sensor's output voltage may drop below 0.20 volts or exceed 2.51 volts, indicating that the sensor's readings are out of the permissible range. The PCM utilizes this information to adjust fuel delivery and ignition timing, thus ensuring smooth vehicle operation. If the readings from the APP Sensor B stray from their normal range, the vehicle's performance may suffer, manifesting as hesitations or erratic throttle response. This component plays a vital role in ensuring an efficient power delivery system in the Honda HRV. Several potential causes are linked to DTC P2126. Firstly, a faulty APP Sensor B may generate out-of-range voltage readings due to internal component wear or damage. Secondly, wiring issues such as damaged, frayed, or corroded wires can interrupt the signal path, leading to inconsistent voltage outputs. Lastly, failures within the PCM, which processes inputs from the APP sensor and issues commands based on those inputs, can also trigger this error code. Each of these factors must be carefully evaluated during troubleshooting to determine the root cause of the issue. Addressing the direct source of the problem is vital for restoring normal operation and preventing repetitive error codes, ensuring the long-term health of the vehicle's throttle control system. Symptoms associated with DTC P2126 can significantly affect the driving experience in the Honda HRV. One of the prominent symptoms includes poor throttle response, where the vehicle might hesitate to accelerate even when the pedal is pressed, leading to a frustrating experience for the driver. Additionally, the engine performance may become erratic, with sudden drop-offs in power or unanticipated shifts in engine speed, which can compromise safety during driving. Another common sign is the illumination of the check engine light on the dashboard, alerting the driver to the underlying issue. If drivers notice these symptoms, it is critical to address them promptly to avoid worsening the vehicle's condition. Ignoring these indicators can lead to more severe vehicle issues, emphasizing the importance of timely diagnostic checks. The first troubleshooting step involves verifying the problem by turning the vehicle's ignition to the on position without starting it. This step allows the diagnostic tool, HDS, to assess the current parameters of the APP Sensor B. Specifically, you will need to check if the voltage reading is less than 0.20 volts, which would indicate a possible failure at the sensor. If the reading matches this threshold, the failure is confirmed, and you should proceed to the next troubleshooting step. However, if the APP sensor B's output does not meet the specified threshold, skip to the second verification step. This initial check is essential for isolating the issue and determining whether the sensor is functioning correctly or if further investigation is required. In the second troubleshooting step, the goal is to reassess the APP sensor B readings. Again, ensure that the ignition is in the on position. This time, you're checking if the voltage exceeds 2.51 volts, which would indicate that the sensor is still malfunctioning. If this condition is met, the failure is confirmed again, leading you to the next step in the troubleshooting process. Conversely, if the readings do not match this threshold, it suggests the failure is intermittent, meaning the system may function correctly at present, but could fail under different conditions. In this case, it is vital to inspect for any poor connections or loose terminals at both the APP sensor and the PCM. This inspection helps rule out any wiring issues before proceeding to more invasive testing. For the third step, start by turning the vehicle's ignition to the off position. You will then disconnect the APP sensor's 6P connector, isolating the sensor from the vehicle's electrical system for accurate testing. After disconnection, turn the vehicle's ignition back to the on position, allowing you to measure the voltage across the designated test points in the APP sensor connector. According to diagnostic specifications, you should be looking for a voltage level of approximately 5.0 volts between the specified points. This check is essential for confirming the integrity of the VCC5 line that supplies power to the APP sensor. If the voltage falls within the expected range, you will proceed to the next step. If not, there may be an issue in the voltage supply line that needs to be corrected. During the fourth troubleshooting step, you'll begin by ensuring the vehicle is in the off position. Afterward, use the HDS to jump the SCS line to facilitate diagnostics, and then disconnect the PCM connector A, specifically the 51P connector. With the PCM disconnected, check for continuity between the specified terminals of the APP sensor and body ground. This step aims to determine whether there is a short in the APS2 wire, which is crucial for transmitting data from the sensor to the PCM. If continuity is confirmed, it indicates a short in the APS2 wire, necessitating repair. Conversely, if continuity is not found, it suggests that the APS2 wire is intact and prompts you to move to the next troubleshooting step. In the fifth troubleshooting step, you will begin again with the vehicle in the off position. Connect a jumper wire between terminals A and B at the APP sensor 6P connector. This setup allows you to conduct a new continuity check while the APP sensor is disconnected and ensures that you're testing the integrity of the wire leading to the PCM. You will then proceed to measure continuity between the specified test points, looking for consistent signaling. If continuity is observed, this confirms that the APS2 wire is functioning correctly, leading you onward to further diagnostics. However, if continuity is absent, it indicates an open circuit in the APS2 wire, which requires repair to restore proper communication from the sensor to the PCM. This step involves reconnecting the PCM connector A after ensuring all prior tests are complete. Once secured, you will remove the jumper wire from the APP sensor's 6P connector and set up a new connection by joining terminals A and B for testing. After this setup, turn the ignition to the on position once again, preparing to check the APP sensor B output through the HDS. The goal here is to see if the voltage reading drops below 0.20 volts, confirming that the sensor is indeed faulty. If this threshold is met, consult authorized service information for guidance or replace the accelerator pedal module as a resolution. This troubleshooting step is pivotal in confirming whether the sensor itself is the primary source of dysfunction. For the seventh troubleshooting step, Turn the vehicle off to ensure safety while working on the wiring system. After powering down the vehicle, again jump the SCS line and disconnect the PCM connector A. This setup is crucial for conducting a wire check, specifically focusing on the VCC5 line, which provides power to the APP sensor. You will connect terminals A and B using a jumper wire to check for continuity between the specified test points. If continuity is confirmed, it indicates that the VCC5 wire is functioning as intended. If not, this suggests an open circuit in the VCC5 wire, necessitating repair. Understanding the status of this wire is essential for ensuring proper voltage management to the APP sensor and prevents further operational issues. In troubleshooting step 8, ensure that the vehicle is in the off position before proceeding to disconnect the APP sensor's 6P connector. Once it is disconnected, power the ignition on again and measure the voltage at the specified terminals. Ideally, you should find a voltage level close to 5.0 volts. If this is the case, the indications point towards replacing the accelerator pedal module as the definitive resolution to the DTC P2126. If the voltage fails to meet the expected value, it signals other potential issues that might still be at play, leading you to the next round of diagnostics. This step is instrumental in confirming the operational state of the APP sensor and its supporting components before committing to replacing any parts. The final step in the troubleshooting process focuses on ensuring the integrity of the SG5 wire line, which is key in transmitting signals back to the PCM. Start by turning the vehicle to the off position and jumping the SCS line once more. Then disconnect the PCM connector A. This sets the stage for checking continuity for the SG5 wire effectively. By using a jumper wire between the APP sensor 6P connector and body ground, you're looking to confirm whether there's a solid connection all the way through to the PCM. If continuity is established, it indicates that the SG5 wire is functioning correctly and suggests that no further action is necessary. If continuity is lacking, however, this points to an open circuit requiring immediate repair to restore effective communication between the APP sensor and the PCM. Once all applicable repairs have been completed, it's crucial to conduct a final verification to ensure the vehicle is functioning as expected. Begin by checking the check engine light's functionality. It should remain off following the repairs, indicating that stored DTCs have been resolved. Following this, a test drive of the vehicle is essential to assess if the issues previously experienced with throttle response or acceleration have been rectified. During the drive, observe how the vehicle performs under various driving conditions to confirm that the throttle system is operating smoothly. Finally, revisit and verify all repairs and part installations to ensure everything is properly connected and functional. This final verification ensures that both the underlying issues and any related symptoms have been addressed effectively. Preventive maintenance is key to avoiding future occurrences of DTC P2126 in the Honda HRV. One of the best practices is to perform regular checks of the APP sensor and its associated wiring to catch any signs of wear, corrosion, or loose connections early. These inspections can serve to ensure that electrical connections remain solid and functional, minimizing the risk of signal disruptions over time. Additionally, staying updated on any manufacturer software and firmware updates for the PCM can provide enhancements that improve the vehicle's overall performance. This combination of regular sensor diagnostics and electrical component inspections will go a long way in ensuring the longevity and reliability of the accelerator pedal system, and by extension, the entire vehicle. In conclusion, DTC P2126 signifies a malfunction involving the app sensor B within the Honda HRV. It is imperative to conduct thorough diagnostics to pinpoint the root cause of any related issues accurately. The troubleshooting process involves multiple steps aimed at confirming whether the app sensor, wiring, or PCM is at fault. Regular preventive maintenance and timely checks can significantly reduce the likelihood of running into this issue again by adhering to recommended practices and consistent vehicle monitoring. Owners can maintain improved operation and longevity of their vehicles. Ultimately, addressing concerns related to DTC P2126 not only enhances performance, but also ensures a safer driving experience. Please like and subscribe to the channel. See you next time!